Let's attempt a problem now where we will make use of the trajectory equation. A projectile is launched with a speed of 70 meters per second at an angle of 30 degrees with the horizontal. The projectile goes on to strike a building which is 300 meters away. So we are given that the x displacement would be 300 meters. We have to find the height at which the projectile would strike the building. Now let's see how the projectile would go on to strike the building. So we are given that this x is 300 and we have to find the y displacement. Since no information is given about time and we have been given the x displacement and we have to find the y displacement, this is a classic case where we will use the trajectory equation that we had derived in the previous lesson. Let's use the one that was easy to remember, which is y equals x tan theta times 1 minus x over r. So here we know x, we know theta, but we have to find the range r before we proceed. Let's do that first. To compute the range, you have to understand that although it strikes the building before it lands on the ground, the meaning of range is the distance that the projectile would have covered when it lands back on the ground without bumping into any obstacle. So for the computation of range, we have to suppose that there was no building in between. So this is the entire range that we have to compute. This is r. And r is v0 squared times sine of 2 theta over g. Now substituting 70 for v0, 30 for theta, so 2 theta would be 60 and g is 10, we obtain the range as 424.4 meters. Now let's substitute this back into the equation for the y displacement. So in the equation for the y displacement, we substitute x as 300, theta as 30, and the range as 424.4 meters. And this is again x, which we were given as 300. And with this we obtain y as 50.8 meters. So this is the height at which the projectile strikes the building. Y is 50.8 meters. So this was an application where you can use the trajectory equation. Let's also try to solve this from the first principles. Or let's say that you couldn't remember the trajectory equation. Then how would you do this problem? Let's begin with the x-axis, and we are given that it covers a displacement of 300 meters. We also know that the x component of the velocity, or v cos theta, remains constant throughout the flight, as there is no acceleration along the x-axis. So 300 would be equal to v0 cos theta times the time t. And from here we obtain the time of flight as 4.95 seconds. Now let's make use of this value of time that we have computed to compute the y displacement. Now we focus our attention on the y-axis. We have the initial y component of velocity, v0 sine theta, and we have the acceleration as minus g, as this is opposite in direction to the velocity. And we also have the time which we had just computed as 4.95 seconds. From here you can see that the y displacement using the second equation of motion is also 50.8 meters, the same as we had obtained from the trajectory equation. So you can see that if you don't remember a formula in projectile motion, keep coming back to the basics, which is we can use the motion equations independently along the x-axis and along the y-axis. In this lesson, we learn how to apply a trajectory equation to obtain the y displacement. For this particular problem, we could have used any of the three forms of the equation, but we chose the one where we had to compute the range, as you can understand what the range meant in a problem where the projectile does not complete its full path. In case you do not remember the trajectory equations, you could always fall back on the concept that you can apply the motion equations independently along each axis. We can find the time required for one of them and insert that value of time into the other equation.